So let's use this formula to find the area of a torus. Okay, torus, which is one of the most important forms or solids in math. This is just like a donut, right? This is what happens when you get a circle and you rotate it around the y-axis. You get this form. Okay, it's a very interesting solid, torus. So let's see, what's the formula here is, remember, the volume of S is the integral between, let's say, maybe it's easier, how to say, yeah, it's easier if we focus just on the positive thing here, and we realize that the volume of the torus is going to be twice this this solid of revolution if we only take that. Why we do it? Because it's easy to parameterize this. This is this is a circle centered at R with radius a, right? So we have that x minus r squared plus y squared is equal to a squared. So we have that y, the positive, this is equal to y, the square root of a squared minus x minus r squared. Okay. If we wanted to integrate over the negative side, we would have to consider also the negative square root in another integral, but it's obvious that this is going to be twice this area, right? So this is going to be 4 pi I, oh, sorry, the formula is 2 pi, right? 2 pi, the integral between a and b of x fx dx, right? In this case, what we're saying is that our volume is 2 times the integral of this function around the x-axis. So it's just 2 times this. So 4 pi between x is r minus a to r plus a, right? So we're taking only the start and end of the function, and the function is f of x, where first is x and then f of x, which is a squared minus x minus r squared, sorry, dx, right? Now, so we can, let me write this here. We have 4 pi times the integral between r minus a, r plus a, and then we have x. Let's take common factor here to a squared, right? A squared is 1 minus, and then we have x minus r over a squared, right? So the a squared gets out, so you have 1 minus x minus r over a squared. Now this is when we did we saw primitives in unit 9. This is one of those. This is 1 minus something squared, right? This is x minus r over a. The change of variable here is to take this equals to the sine of theta. Okay, so now this is equal to x equals r plus a times the sine of theta, right? Now if we want this integral to go between r minus a, right? When x is r minus a, this means that the sine of theta is pi minus pi over 2, and then when x is r plus a, sine of theta is 1, so that means that theta is pi over 2. So let me rewrite the limits of integration between minus pi over 2 and pi over 2. This is a that goes out, and so we have what, x, which is r plus a times the sine of theta. 1 minus this is the cosine of theta, right? Remember that. So this is the cosine of theta. And now what happens with dx? Well, dx is a times the cosine of theta d theta. So you have a squared out, cosine squared d theta. This is now our integral. Now let's see. Let's see, there are 2 variables here, right? This is, wait a minute. Yeah, so let me go here down. Now we have 4 pi a squared, right? And we can separate this into the first one, r times the cosine square of theta d theta, and then plus 4 pi a cube minus pi over 2 the sine of theta cosine square of theta, right? Now this function is odd, right? Around is odd, yeah. If you the sine of minus theta times the cosine square of minus theta is equal to minus all of this, right? So we are integrating around an interval that's symmetric around 0. This integral is 0, okay? Check one of the exercises from unit 10 if you don't remember this. Okay, so we just need to compute this integral, right? This is 4 pi a squared r, the integral between minus pi over 2 to pi over 2, and the integral of the cosine squared is just, sorry, we can rewrite the cosine squared as 1 plus the cosine of 2 theta over 2, right? So we can divide 2 and 4, so here we have 2 pi a, and this is just like this, right? Now the integral of this is easy enough. This is theta plus the sine of 2 theta divided by 2 from pi over 2 and minus over pi over 2, right? So let me see. This is 2 pi a squared r. We have pi over 2. The sine of 2 pi over 2, this is 0, right? And then we have minus pi over 2 plus pi over 2, and the sine of minus pi over 2 again times 2 is the sine of pi, which is 0. So we have pi here. So you have 2 pi squared a squared r, okay? Or we can rewrite this like this: 2 pi r times pi a squared. Okay, so in other words, this is the perimeter. If you go back here, okay, let me go back here. So the volume of this solid is 2 pi r times pi a squared, right? So this is just very intuitive to see, right? We're taking the area of the circle, okay, has a radius a, so it has area pi a squared, and we're multiplying it around it a circle that has perimeter 2 pi r. Okay, so this is another way of thinking about this area, right? Another maybe more intuitive way. Here we have solved this using integration.